Okay, guys, so here is a kind of crude picture as to, for me to try to explain what's going on visually with sort of a diagram. So we've got the BCM, ABS, cluster, radio frequency hub, and the radio. The ABS communicates on what's called the CAN C. So does the cluster, so does the RF hub, and the BCM has multiple buses on it. Obviously, one of them is going to be the CAN C. This IHS is kind of like a lower speed, kind of body type bus. And the radio is on, out of these that I've put on here, has both buses on it. Now, being that all of these are on the CAN C, you can start to see as to why that was lit up, why that was drawing on the fuse, why this was hot on the thermal imager, and then obviously we know this guy is acting up. But the reason why we are seeing what we see with the high level of draw, let's call it, is because when this guy decides to act up and it's plugged in, it wakes up and starts talking. And it talks on the only communication line that it can talk on, and it sends messages on that CAN C. Now, all of these are tied into what they call a star connector. So it's one long, kind of like a comb connector, and they're all just tied in so that all the bus high are attached, all the bus lows are attached, and that's how they all communicate. So this will send messages, and they're all seeing activity on the bus. So he stays awake, he stays awake, he stays awake, he stays awake. All because this guy's talking. Now, when they're all awake, they're obviously going to draw amperage off of the battery because they're staying awake, and that's where you get your elevated levels of amps. And once we start removing them, we start bringing that level down, but still not fully eliminated because there's still a problem. So then we have these two guys left, and because a part of me doing this is to try to explain which is the true cause, because on my last video, the one that seemed to be having the draw was not the cause of the problem. It was an input to that module that was making that module look bad. And so in order to determine which one of the two, because we can always argue that the BCM is waking up the ABS, and then obviously we can argue that the ABS is waking up the BCM. And so when we basically remove this, if then our amps again drop down and stay down, it means that this guy now can go to sleep because it's not receiving any messages on the CAN C if these are the only guys left on there per se. And so that goes to sleep, so it doesn't consume amperage. Our level goes down and stays down, and nothing else wakes up, and that's where our acceptable, I think it was 20 milliamps level is where we were at. So the fact that when this is removed, nothing else is talking and nothing else is drawing, particularly this guy, that tells us for sure that is the problem. And sure enough, again, when we reconnect this and this wakes up to the point of failure and doesn't go to sleep and starts talking, it wakes this guy back up, and we get back to our 700 plus milliamps of a draw when that guy is in circuit. All right, guys, so if you look, we are back down to the 20. I'm going to try to do, which I don't even know if I need to, but a final type of dagger test. So ABS modules removed, hence the lower value, and I'll show you my setup. Okay, so I've got the ABS module here. This is the diagram for it. We've got one power that's hot all the time, and then the second one there. We've got a ground there. We've got a ground there. 2 powers, 2 grounds. So 2 grounds, 2 powers, and then 2 bus lines, which are right there. So I am going to power up the module, and then I am hooked up with my scope to check the bus lines. Okay, so I'm making my power and ground connections, and I will let you know once I supply the power, which I will do now. Alright guys, this stuff never ceases to amaze me, but I'm glad that at least I keep going with persistency in trying to, get those bullets, those final daggers, so on and so forth. So now you see what I've got set up here. This is similar again to my last one. I keep referring to my last one because it was a good learning lesson. So again, I'm trying to follow those same steps to not get in trouble. So let me show you what I'm talking about. So I've had the power supply on and no activity on the bus. And the bigger clue is this would be our amperage reading. We are currently supplying and there's 0 amperage. So power, ground, here's my bus, our scope, so on and so forth, and 0 consumption of amperage. Now this is the guy, when plugged in, was causing the draw. So, which I saw earlier, I didn't think would make a difference, but again, when you assume, you know the rest of that phrase. Let's look at this guy here. So that is another power supply. It is only hot with runner start. I didn't think, since the car is off, or the truck is always off when we have issues, I didn't think I needed to supply that here. Again, 0 amperage, not waking up, 0 bus activity. And now if we come to the car, again, obviously we're going to be down at a good level. If you see what I've got down there. So I've got, the blue one is in pin 8, the green is in the ground. What do we have here? We've got 3.5 voltages on that key on power supply pin for the ABS. That should be at 0. I think, as much as I just previously condemned the ABS, I still haven't replaced it because I'm still doing testing, luckily. I think that this is the cause of waking up the ABS module, which then down the line makes everything else act the way it does. And without going to this extent, or the bench testing, so on and so forth, or looking at this, I would have made a wrong call. Now I'm still, again, assuming because of what I'm seeing here. So now I have to continue on and do further testing to figure out what's going on with this, and I might want to try something with the ABS on the bench. Okay, so what I am going to try to do, I've got pin 8 here. I've got just over 3.5 volts that I will supply. I've removed the power supply from the big cables. I might need to put that in. So I'm trying to simulate, again, the car's condition. I still have my ground to the power supply. So let's see if this will work. So here is this guy. Let's do that actually. Let me go under here. And then I will hit supply. And still nothing. So no bus yet. I'm wondering if I have to supply this power here also. But this has to be 12 volts on these two pins. Okay, I just turned on the 12 volt independent supply. Now I will turn on the 3.6 volts. There you go. We have bus activity. There is our 3.6, and I've got my 12 volts through that box, but we have now woken it up by having the 12 volt constant on the big fat wires, and then independently providing in the, let's see, this guy, I think. No, that guy. Sorry. Pin 8, 3.6 volts. We have woken it up, and there is our bus activity. That's what's shooting out from this guy to the rest of can C and wakes everyone else up. So this guy is only waking up because pin 8 is being supplied with 3.6 volts. And we clearly see it there. And I just turned off the 12 volt supply and it kills our bus. So let me stop the 3.6. And again, no activity. So it has to be a combination of both. The constant 12 volts and then the 3.6 in order to wake that guy up. Okay, and lastly, what I've done, just again now, out of curiosity and just for over verification, I'm going to read the amperage to the 12 volt source because we've got a amp meter there, which we're showing 0 on our small voltage supply. So out of curiosity, I want to see what our amperage is there on the 12 volt circuit portion. Which I believe is what we see in the car. That's going to be in the green. So let me start this over. And I am going to go with, let's see, I'm going to go with the 12 volt power supply on first. There we go. So we got a little bit of a rise there. Now I'm going to do the 3.6. And there you go. Look at that. That is what we were seeing on the Vantage Pro. That repetitive module activity. That's crazy. Let me see. There's the 3.6 turned off. And then with the 3.6, now we don't have the repetitive thing, but we still have a draw there. And let me turn off the constant. There we go. Let's get some numbers here. Let's see what we are looking at. That's pretty cool, though, that we're seeing the pattern here. So let's go over at this point. All right. So as far as our amperage with constant on, let's see, 70. right there, 70 milliamps with our 12 volt only. And let's see what it jumps up to. So 359. So this guy alone here on the bench is pulling 360 milliamps by itself. Now, if you remember, the draw was almost at it was between 700 milliamp, like 770, up to just over 1 amp. So this guy alone is, just under 400 milliamps of that whole 1,000 milliamps. So you can see where the rest of the BCM will bring up the rest of the amperage. And again, this is what I speak about when, by going off of amperage reading, if it's elevated so much, then it has to be constant or multiple modules if you're having a weird amperage pattern. With a repetitive, weird constant pattern, it has to be attributed to a module, and then if the amperage level is high, then it's multiple modules. If it was lower, if it was just at 360 and we have this pattern, again, we'll attribute it to a module because we have a pattern, but possibly just one because our level is lower. Again, that is right here mirroring the amperage. So again, this is why me personally, I've never got into or learned to or used the scoping the bus, because you're seeing it all on the amperage. Like if there's amperage and there's a repetitive pattern, then there's gonna be talk on the CAN bus or a bus communication. So not saying it's wrong, but I just choose to watch and decipher this amperage pattern and attack the draw based off this, and I really haven't had to start looking at buses when chasing the draw. Okay, so that guy there, that's the run start relay in the power distribution, which is the one that feeds, or would feed here, all these fuses, and 76 goes to the, here, let me show you, ABS down there. So what's crazy or funny, not funny, but all these other components, so all these should be receiving the 3.5 if that fuse is, and I'll quickly check, but I bet you all of them are, and they obviously feed other components that some are modules, like the power steering, BCM, actually that's the control for the relay, PCM, airbag, steering, so on and so forth. So some of these maybe are not affected with the low 3.5 volts, but for some reason the ABS is, and because we know that's the only guy that's awake based off the pattern in the amp meter on the Vantage Pro, and then when we remove it, we go down to the 20 milliamps, even though all these other fuses will still have 3.5, because I think at this point we can maybe just blame everything on possibly sticking run start relay pins there. So crazy, but let's go finalize this and verify. Okay, so that should be the run start relay, and let me see, here's the meter. So I wrote down all those fuses that are on the same leg, but I think this one, so that's 72, 3, 4, 5, 6 is the ABS one, so 3.5. Let's go 75, 3.5, and so the rest of this leg, again, all of these will receive, or that whole leg of all those fuses will receive the 3.5 from that guy there. Now, just again to verify, we are still at 20 milliamps, which is a beautiful number. One thing to a disclaimer. Let me show you. Look at that. Now, I don't know if that was from the shop or the dealer. I doubt it was from the dealer. It sounds like they didn't do much, but someone possibly, or the customer, someone was considering, or I don't know if this was replaced. It's kind of dusty, so let's go look. Okay, so the rest of them do have the same, let's call it stamping. So I don't know which one they maybe were messing with, but I'm going to swap this with that. So let's actually, okay, so we'll try to do this simultaneous. So let's take this guy out, and that's not it. Oh, all right. So let's see, I've removed this. Let's just check all these pins. There's 3.5, and the last pin 12.3. So yeah, it's not going to be a relay. Oh Lord. 3.5 internal to the, right now, the fuse box. Okay, so here is the diagram of that run start relay. If you saw when I was checking on the pins, one of them had 12, one of them had 3.5. I'm assuming this one was the 12, which is feed from, I guess, internally. And initially I was thinking possibly the whole fuse box could just have an internal issue or problem, which it might still or might not. I don't know. But this one has to be the one that showed 3.5 with the relay removed, because on that pin we obviously are tied to these fuses that when the relay was installed, I was checking and 3.5 was there. Obviously now we know that the relay is not making a difference. I was thinking maybe it was attached here, not fully, contact, and it was letting about 3.5 through to the fuses. But obviously relay removed, 3.5 there, 3.5 there, so on and so forth. So what I am trying to explain is the only way to get 3.5 there on that pin is for it to come from somewhere and tie it into this line. So right now, the easiest, most logical approach and thing to do is I'm going to pull the fuses one by one to try to see if that cuts 3.5 power coming up through any one of these lines. And I'm going to monitor here with the meter while pulling these fuses and see if 3.5 drops out there at any time and point. So all of these, let's see, are fuses, and then it ties here, goes down, that's still that same circuit, and then it goes to AC clutch relay, radiator fan relay, vacuum pump relay. So these are relays right here, the same circuit, and then the rest are fuses that go to other components like I explained earlier. So I will start pulling fuses. I'll keep you on the watching the meter, and I'll pull one out, and then if it makes no change, I will put it back in. So let's see. I'm gonna start with fuse 75. I'm gonna pull that out now. No change. Putting it back in. And affect it. Next one, 76, which is the ABS one. No change. Putting it back in. Next one should be 77. And there we go. We'll drop down to 0. Let me get you a quick shot. So, this guy, 77. I'm gonna, let's see, install it back in. There we go. So, 100% again, truly the source of bringing 3.5 volts back up into this line, which then ties into that relay. So that was 77, right? So 5, 6, 7. Let's verify again. So let's see. Removed. Okay. So 77. Let's see where that goes. Alright, so fuse 77. Looks like it comes down and actually splits off into 2 other modules, of course. Let's see, drivetrain control module and front axle disconnect module. So let's see. Alright, I guess we're gonna have to go to one of these guys and see what's going on there. Let's find out where those guys are. Alright guys, so it's time for an update. I've been messing around with it since last I had the camera up, which we left off with fuse 77. When removed, took away the 3.5 volts to that whole leg of fuses, which then we determined that went down to drivetrain control module and then basically the front axle actuator deal. Then I went to those components, removed them off the circuit to see if that voltage went away. Now, the front actuator deal is that guy there. But what I ended up doing was I unplugged the feed that goes down to it. And then the other module, the drivetrain control module, so this one took a minute to kind of find, is that guy right there. And obviously we've got those unplugged from that module. And the weird voltage at the fuse box did not go away. So the one thing I noticed was when we removed fuse 77, obviously we lost the 3.5 volts. But I decided to probe the one end of the fuse leg, and it was actually like 12 volts. So it basically is backfeeding 12 volts into that leg, and then when it goes and gets distributed basically the wrong way, it comes down to 3.5 once it's spread out through that leg improperly. And so fuse removed on that leg, we have 12 volts constant there. And so I unplugged the got the one module and the actuator, and we still had 12 volts here at the fuse box. Now it starts to look like internally again potentially an issue with the fuse box. So then my next step was to make a kind of a final determination, was that leg that leaves the fuse 77 wire, was to find that wire, because that is obviously where it's coming back and feeding 12 volts. So we know it's not from the module and stuff coming this way on that wire. So I wanted to, at the source, basically, find the wire. Source meaning this guy here, if it's internal to the fuse box. And it's like a pink and green wire, it's described as. And I ended up basically finding it. And at this point, you know, patience is getting a little thin. I've been here for hours, and so I just went ahead and I decided to cut that wire. Now, the one side, I'm going to check this side, which is goes out to the rest of the car. This is for the fuse box side. So basically, to see if we have an internal fuse box issue, we'll have voltage on that wire. If it's something else bringing the volt in, we'll have voltage there. So if we look at the meter, we touch the fuse box side, we have nothing. And if you can imagine, if we touch that side, we've got our 12 volts. So something on this freaking circuit that's supposed to go out to the actuator and module inside, with those two unplugged, we still have 12 volts there. So what does that tell me? First of all, it's not the module actuator. Second, it's not the fuse box. So again, more and more and more that if I keep finding out that it's not. You know, we thought we were going to find that after we thought it was going to be ABS. You know, then it's not the fuse box. It wasn't those module actuator. There's something, you know, on that circuit keeping 12 volts. And if I don't figure out what that is, we'll never get rid of the back feed in here, which then feeds that leg, which then wakes up the ABS, which then gives us a draw, so on and so forth. So I am stuck now trying to find out the source of the 12 volt feed here. And it is now 6 o'clock. Again, patience is running thin, so don't scold me about cutting this wire. I'm trying to accelerate the process at this point, and I will obviously make a good connection here, but I have got a ton of time on this, and I'm still not at the end of the road. Okay guys, so I think I finally got some good news. So what I ended up doing, I just wanted to verify. I checked the pin that feeds this guy here to see if there was 12 volts, and there was. So after cutting the wire there that feeds down here, there was 12 volts down here. And so I was looking again at the path, or trying to. So that's the harness that goes down to the actuator. It comes up along there, along the fender, and then it goes down there, and there is a pass through. Let's see if I can get you a shot of it there in that rubber above the PCM. That's a pass through. That's where it would go. But there's nothing else down here, so I decided to just basically unplug that junction that goes to the engine computer, and then looks like the engine harness. And so I decided to split that junction connector there. And once I did that, I measured voltage inside at the drivetrain control module, and it went away. So we clearly have some sort of issue at this junction. And as I started to look, and this is going to be difficult, but I'll do my best. So let's take a look. Okay, so it's really grainy, but you see the see that water and some discoloration. There is water in that connector, and then if we look at the other end, so there, the bottom pins there, you can see where the discoloration is. Naturally, that's the bottom side. That's where the water will settle or sit down at the bottom. And so I haven't looked at the wire colors or what pins those are or whatnot, but I bet you that water is joining some 12 volts to our feed, or whatever that wire you want to call it. So yeah, after tons of hours, unbelievable. So that's gonna be our cause there. Alright guys, so it is now the next day. Last I left, I was showing you the connector. I ended up cleaning that out, blowing it out really good, drying it, cleaning it with some solvent, let it air dry. Even after that, I actually used the heat gun as well, and just blew a lot of the water out to the point where no more bridging of the voltage to that one pin that then supplied voltage back up to the fuse box. So everything is back together and good. I've reinstalled every single component that I removed from the inside, the interior, to the engine bay, so on and so forth. Even got obviously the ABS, there we go, reinstalled, and I'm just doing one last final check. Today is the next day. So there you go. Everything is put back together, reassembled, and no more draw as we would have expected after what we have found. So there we go. We are at an even better number than the 20 milliamps. So let's, not that we have to, but so look, just under 10 milliamps. So we're perfect. This vehicle is 100% fixed, rectified the issue, no parts needed, just water in the connector. Alright guys, so I'm going to finish this off now. I don't know how long this video is going to be. Again, I'm finishing this up. This will be picked up tomorrow. But I will tell you, this to the date has been the most butt-kicking battery draw that I've had to deal with, probably of all time. Most of them do not lead me this much of a, it takes you to one step, and then it's not that, then the next, and then it's not that, then the next, and then next, so on and so forth, where, I just have not had one do that to me yet, especially to this extent. I mean, if you think about it, I mean, I've got crazy amount of hours. I think ballpark that what I've got written down, somewhere around 15 hours. That's 15 hours of sticking to it, following the data, knowing what to look for, knowing how to test, what to test, what everything meant, whether it was good or not, or to keep going and testing more or not. If you think about it, how many times could we have stopped and made a call from the very beginning where the cluster stays hot or lit up, or the radio stays hot and powered up, or the fuse box, the relay, the ABS that was almost the one that I made a call on. Like that right there by itself, along with all the other stuff that could be common, is so many points where I could have, someone else could have stopped, said, hey, you need this is the cause, this is what's drawing, so on and so forth, and we still would have been on the same boat. You still would have had a draw, and you would have been wasting time and money and an upset customer because there's still going to be a draw and they've spent money with you. So, just wrapping this up, I hope you guys enjoyed this one. As much as it ended up becoming a pain towards the end, it was just getting frustrating because it just felt like it was never ending. I really enjoyed finding the cause without making the wrong call, all in one true visit without, multiple returns, so on and so forth, which I always strive to hit the nail on the head the first time. So that is the extent of why I test the way that I do. So hopefully customer is happy. It's going to be all a charge of just diagnostic time, the time I got in it, but there is no money incorrectly spent here, like what he did with the dealer. Paid him a stupid amount of money too to replace a battery, and supposedly no draw, and then when you pick it up, you need to jump start it. That just makes no sense to me, but that won't happen. It's all fixed, all good now. I'll be finally happy to see this gone, and that's it for this one. So thank you for watching as always, and we'll get this wrapped up.